in our compound interest formula that we talked about at the beginning of the seminar, we have, it's very simple, similar to exponential growth, but it just has a different variable in there, your n. N stands for the number of times you compound your interest in a year. So if you compound it once a year, n would be 1. That would look just like your exponential growth formula. But if you compound it twice, then we have to put in 2 for n, and so on. So let's take a look at example 5 with Harper. Harper has $5,500 she earned over a summer job, and she finds a savings account that pays 3.25% compounded quarterly. Quarterly means n is going to be our 4 then, isn't it? Because it's 4 times a year. I want to know how much money is going to be in your account if she leaves the money in the account for 5 years. So we're going to say A equals P, which is 5,500 times 1 plus your interest rate, which is 3.25%. So we're going to write that as a decimal, 0.0325. And we're going to divide that by 4. And when I take that to 4, n is 4, and she's going to do 5 years. So it's 20. So we can simplify that a tad. I don't know if we're going to have to simplify it that much. So we're going to go 5,500. If I take 0.0325 and I divide that by 4, you get 0.008125. So it's 1 plus 0.008125. We're going to raise that to the 20th power. So let's just type that in our calculator. So I'm going to say 5,500 oops, I got one too many zeros. So 5,500 times 1.008125, and we're going to raise that to the 20th power. And at the end of 5 years, she'll have $6,466.22. $466. And what do we say? How many cents? 22 cents. And there's your answer. And that's what we do. Now, exponential decay means it's going down. So the only difference between exponential decay and exponential growth is we are going to subtract that r from right there. So we're going to minus our r to show decay. It's going to be less than 1. So what happens if we take a look at example 6, in banking, a dormant account is one that has not been used in over a year. A bank charges a monthly fee on a dormant account of 0.8% of the account balance. Once the dormant account is initial had a balance of $1,609, I want to write an equation to represent the balance after T months, and I'm going to estimate that balance after 1 year. In other words, not only do you not make money, they're charging you money to keep it in the bank. So we're going to say y equals, we started with $1,609, and we are going to subtract 0.8% as a decimal. I take 0.8 and I divide it by 100. That's 0.008. So 1 minus 0.008, we're going to raise that to the t power. So I can simplify that a little bit. It's 1,609 times, if I take 1 minus 0.008, It's 0.992. I'm going to raise that to the t power. Well, after 1 year, I'm just going to replace t with 1. So you take 1,609 times 0.992, and you get $1,596.13, we'll round it to. So you're losing, based on that balance, we're losing some money each year, aren't we? That's what exponential decay does. It decreases it. So you're losing about $13 every year. You keep it in the bank account. Now it's going to go down each year because you have less, just like exponential growth. You're only taking 8.8% of 1,596 the next year, and so on and so on.